Hey everybody, today I will do another quick math problem, and today we will basically do some we will continue on the derivative using the definition of the limit um, and of the definition of the derivative, right? I would say that here you can see that in the last video I missed that f here. So technically that is m pq, right? So okay, so the problem that we'll be doing is it's a problem that we will see if maybe we can do two problems. I don't know yet, or maybe one, right? But it's all depends. So the problem is like this. So you got f of x is equal to 5x squared minus 4x, right? And we will still use this definition of the derivative, right? So we say that a is equal to x, right? In that formula. So whenever I see an x squared or an x, I will substitute a plus h. But in the last part right here, I am subtracting the function. I am subtracting the function, which I am subtracting this function evaluated at a, which is the same thing as saying evaluated at x. So basically, I am subtracting this function, right? In this part, right? This right here, right? So, okay, so let's do this. So we got 5, right? And let me just put 5, right? And then here I get x plus h, right? Square, right? Minus, I got a 4 right here, so minus 4 times x plus h, right? Minus the function, which is, but be careful here. See, this is very easy to make mistakes. Here, I can actually just put a bracket here and then subtract the function, which is 5x squared. And so, and it's a good idea to put the brackets too, right? So here we'll put 5x squared minus 4x, right? Just like that, everything divided by h. At this point, I can actually distribute this, right? So I can say that 5 times x plus h times x plus h, right? Minus 4x plus h, right? And then minus that, at this point I just distribute the sign in there and I get negative x squared minus 4x. Actually it's plus 4. See, when I distribute the sign across in this bracket right here, I get here plus 4x, right? Now everything over h, right? Now, when I do this math here, I get what? I get 5, and then I get x squared plus h plus x, right? Plus h, okay, plus hx, right? Plus h squared, right? Minus, I distribute that sign right here, and I get what? I get 4x minus 4 minus 4h, right? Minus 5x squared plus 4x, right? Okay, so this is everything over this h, right? Now, when I do the math here, okay, so I get 5 times x squared plus 2h x plus h squared, right, minus 4x minus 4h minus 5x squared plus 4x. Everything over right? Everything over h, right? Now I can distribute that inside this 5, right? This 5x, and but also I can start canceling some stuff up already. But I just do everything and then start canceling, right? So I will distribute that inside, and I get what? I get 5x squared, right, plus 10hx, right, plus 5h squared plus 5h squared, right, plus 5h squared minus 4x minus 4h, right, minus 5x squared plus 4x. Everything over h, right? Now I can start canceling some stuff up, right? So I can cancel this, I can cancel this, right? This 5x squared, this 5x squared, right? Cancel each other out. I can actually cancel this 4x, and I can actually cancel that 4x, right? So now over here I get what? I get 10hx plus 5h squared minus 4h, right? Minus 4h over h, right? So notice that I can factor out h, right? And I get what? If I factor out h, I get h times 10x inside here, and I get plus 5h, right? Because I take 1h out, I am left with 5h inside, and here I take the h out, I only get minus 4, right? And everything over h, right? Now notice that this h cancel out, right? And I forgot one thing, that limit h approaches 0 all across, limit h 0, because the book doesn't teach it though. The books tell you to assume. So that's why 0, and same thing here, limit h 0, right? And all the way down, limit h 0 and limit h 0, right? Now, now I am left with what? I'm going to this board now, and I am left with what? 10x, sorry, I don't have an h there anymore. I have 10x minus plus 5h minus 4, right? Now, but we say that limit h approaches 0, right? So if we replace that, we say 10x, right? Plus 5 times 0 minus 4. And so the slope, which is the derivative, you can say that, you can call it whatever. You can call it m, or you can call it whatever. F prime is equal to 10x minus 4. Right? So, and I think I said in last video that f prime is the same as dy dx, right? This f prime is the same thing as that. Also, it's the secant line, which is the slope of the tangent line, right? The slope of that tangent line. I'm sorry, not the secant line. It is the same as the slope of the tangent line, right? So this is basically the same as prime of x, or you can say also the slope of a tangent line, right? So it's the same thing. You can velocity. What is the velocity of the of this particle? It's the same thing. Talking about derivative, right? The second derivative usually give you this the acceleration, but it's basically the same thing. Dy dx, f prime of x, right? And this notation was done by Isaac Newton. This one was done by Levens. I think that's how I think that is the way you pronounce it, Levens. So Levens came up first. Isaac Newton came up with this, and then this is the Newton's notations. This is the 11th notation, right? So that's how you recognize the y dx, which is basically the changing y over the changing x. That's what it is, right? So, which is the same thing as the slope of a line, basically. But we're dealing with curves, right? So that's why we call it tangent line. See, in this case, you have a positive slope, right? Here, you got also positive slope. Why? Because it's a positive 10x, right? That might just be crossing like this, something like that. It's crossing a negative 4 on the y-axis, so it will look like that, right? But it's still positive. It's going in a positive direction, right? So, so that's how you do that's how you use the definition of the derivative to actually take the derivative of a function that is in form of a curve. You can see right here as a parabola, and then you get a 4x, right? So it's the same thing. And this is very easy to take the derivative, which I will be doing regular derivative with the power rule. You just take one step and you're done, right? With this definition of the derivative, you do a lot more math, but I think it's a good idea to understand how this works. You know, how you minus. See, you minus this, you minus this piece, you're subtracting this point. So what I usually look at this is like when you want to find the average velocity of a particle that is moving, right? So you say, maybe, final minus initial divided by this, so, by this type of, distance, or whatever, final minus initial. That's how I look at the thing. And, if I am thinking about velocity, final velocity minus initial velocity give you a certain distance, right? And then, based on that, you can calculate other things. All right. Again, thank you for watching, and I hope you learn, and you learn something out of this problem that we solved today, and that's the whole purpose of it. My whole idea is to kind of give you different techniques how you can actually solve problems using this beautiful formulas that were derived for us of this concept, the concept of a seeking line getting close to the curve, and getting close to the curve by going by making this H coming close to A, right? Or making this piece coming close to A, well, in this case, and then you kind of the tangent lines, the seeking lines are getting closer and closer and closer until they become a tangent line, which is the slope of a curve, the slope in a curve, right? In this case, the derivative was taken here, but also if we take the second derivative, of here too, you can have another derivative, touching that line. So yeah. So this is the basic concept of using the definition of the derivative to take the derivative of a certain function. Right? Thank you for watching.